Hi guys, in today's session we'll be doing session 2, continuing from unit standard 14921. So the title for session 2 is describe categories of computer system applications, and in today's sessions we'll look into the computer system applications, the categories, and there's so much that we'll tackle in this, and also I'll emphasize in terms of the embedded system. So moving on to slide 33, the categories of computer system applications. So we've got embedded systems. So let's take a look at embedded systems. So in just in a nutshell, an embedded system, it's a system that is being embedded into it. Like for instance, I'll just make a practical example that I know it's not even relevant, but just to think of it, like when you are saying you're embedded, it means that there are certain functions within it. You've got your brain, you've got your heart, which has functions within you as an individual, which can perform other things. So your brain consists of your nervous systems, where it can, each and every movement that you do, your brain and functions, those kind of movement. So similar with your embedded system, it's just a combination of hardware, computer hardware and software, which are designed for a specific function. So also the system can be programmable or fixed, or have a fixed functionality. It depends if maybe you pertaining to that type of system that you want to its function is, it will be programmable based on that. And also they may be function as a standalone devices or as part of a larger system. It varies also. So there's a couple of embedded systems that are in place, which serves as a standalone devices. You may have your ATMs, for example. It contains both your computer hardware and software designed for consumers or customers or clients that can be able to access or maybe be able to withdraw money. So it's more of your standalone device, which contains both your computer hardware and software. Also on slide 34, we have the embedded system comprises hardware and software that work together to perform specific tasks. Also, they rely on microprocessors, microcontrollers, memory, input or output, communication interfaces, and a power supply to function. Also, an embedded systems employs a printed circuit board, which is a PCB programmed with software that tells its hardware how to operate and manage data using input or output communication interfaces. Memory, which terminally produces outputs variable to the user. So this is the main source in terms of being embedded. So that's where most instructions comes from, that PC board, because it was embedded into that system, into any device that you have. So that device within it contains a printed circuit board, which contains software which tells that hardware how to operate, like your standalone devices, like your ATM. It tells in terms of if maybe you want to insert money into it, how, and so forth, and its functions. So those are just most of your embedded systems. So let's move on to slide 35. Slide 35. This is just a illustration of a printed circuit board. So this may be embedded in a device or installed in a device. So these chips contains instructions within them. So a software is installed within this printed circuit board, which employs or tells the components in terms of the devices or the hardware what it should do. So on slide 36, we've got the categories of computer system applications. So an embedded system are a combination of hardware and software, usually which contains the microprocessors I've mentioned and microcontrollers, your graphics processing units, volatile and non-volatile memory, input and output communication interfaces and ports, system application code and power supply. As you can see on slide 35, what I've just mentioned, it's most of like your microprocessors. Like this is your CPU of this printed circuit board, your slots, your port slots, um, and what else? Let's go back just to verify which else. Your memory. Um, so there's so much that a circuit board can contain within it. Also on slide 37, embedded systems are classified based on performance and functional requirements. So when classifying embedded system, these are just based on performance and functional requirements. Embedded systems are divided into four categories. We've got your real-time embedded systems, standalone embedded systems, and also a network or networked embedded systems. And lastly, you've got your mobile embedded system. So we'll look closely into these four categories of embedded systems. So firstly, we'll look at what are the real-time embedded system that is on slide 38. So a real-time embedded system must provide results or outputs promptly. So priority is assigned to output generation speed, as real-time embedded systems are often used in mission-critical sectors such as defense and aerospace that need important data, well, like yesterday. So examples of those real-time embedded systems include like your aircraft controls, your land vehicle and flight computers that process and transmit sensor acquired data. So you can just imagine with these examples being mentioned that output it's instant, it's instant at that particular moment. Like for instance, like your aircraft control communication, in this it should be real time. So those are your real embedded systems. I hope maybe watching this video you'll be able to understand and grasp the concept in terms of what are your real embedded system. And also just to deviate a bit onto slide 45, there is like your real-time processing similar to what the real embedded system is. So with your real-time processing, this is more of how data processing that occurs at the users. It's when data transactions are processed immediately, similar to what the function of a real-time embedded system. So we'll look into the real-time processing at the later part of this video. So going back onto the real-time embedded systems, uh, the examples also include your missile defense system controls, autonomous and semi-autonomous vehicles control. So this is just a package of examples that are that explains what includes an embedded system. So also we have what we call a standalone embedded system. So what is a standalone embedded system? So a standalone embedded system don't require a host computer to function. They can produce outputs independently. So these examples embedded systems include like your digital cameras. So as your digital cameras, they don't require a computer, because you can just use your digital camera anywhere. But within it, inside, it contains that circuit board where you can it within it contains also a software. Also, examples includes your digital cameras, your digital wristwatches, MP3 players, appliances such as refrigerators, washing machines and microwaves, temperature measurement systems and calculators. We know some of us, whilst we were at high schools and tertiary level, we used to fix the calculators, and within it we were able to find the circuit board within it. So that circuit board contains a software which tells its components inside, how it should function. Whenever you click any button, it will automatically provide answers based on the calculations that you do. Same thing with your standalone, it's an embedded system. So on to slide 40, we've got what we call a network embedded system. So a network embedded system rely on wired or wireless networks and communication with web servers for output generation. So examples of network embedded systems includes home and office security systems. So these security systems, you know that it's either they are wired or wireless, and they produce communications. So we know that it's either they are connected to a router where it will just provide or just collect information within these security systems, or it is connected to one of the systems within that particular environment. It could be maybe a server. That server could be a web server where it just provides output based on what it receives. And also you've got your automated teller machines, which is your ATMs. This is just an example in terms of it's your network embedded system. And also you've got your point of sale systems. We find these in your shops like your ShopRite and Pick and Pay. They use the point of sale systems. So these are just your network embedded system. Also, lastly, we have our mobile embedded system. So a mobile refers specifically to small portable embedded device such as cell phones, laptops, and calculators. So these are just more of your embedded system. So we know what is a mobile embedded system. We have been exposed to it. Some of you are having your iPhones, latest iPhones, so that's just more basically your embedded system. So now let's look at the batch processing. It's in slide 42. Batch processing is just a method of using multiple programs to complete tasks and task automatically. Just think of a system where the system, in most cases, it requires to do multiple tasks at once. So let's say, for instance, maybe I'm just making an example, hypothetically speaking. Let's say maybe now we're trying to access maybe Microsoft Office, and we are using Windows, not even Windows, Excel for instance. And Excel requires maybe to do multiple calculations within its task. So when you do a certain calculation within a single cell, and also on the other cell you want to do another calculation, and also maybe about 4 cells within it you need to do different certain tasks within it. So that's more of your batch processing. It uses multiple programs to complete tasks automatically. So an efficient way of processing large volumes of data is what you call batch processing. So this is where you deal with large volumes of data. So data is collected and entered and processed. It's just a process. Data is collected, entered, and processed, and afterward it produces batch results. So for input, it process, and output, the batch processes requires separate programs. For example, payroll and billing systems are examples of batch processing. Also on slide 43, we have another example, which is your sales team, where employees would gather information throughout a specified period of time. So afterward, all that information would be entered into the system all at once. So this whole procedure is known as batch processing. So just think of it when you're having a sales team and you're gathering information within an organization, for instance at Integra, and you've got your different departments. You've got your IT, you've got your HR, you've got your finance, and your marketing team. So you've got about let's say maybe 50 employees within that organization, and you want to gather information, um, personal information for those employees. So that's more of your batch processing. If you can go back onto the previous slide, it gathers it, data is collected, data is entered, and data is processed in terms of the payroll. So you input data, you process and output, and that's how the process works in terms of the batch process. Also, in this method also means that waiting to do everything at once. Also, it means that relying on the ability of your system to handle it all. So just imagine if you had maybe about thousands of users within that organization. So batch processing will assist in terms of gathering information for those thousands of users, being able to collect, process the data, and also producing results based on the thousands users that you have within your organization. So batch processing, it's more of dealing with large volumes of data. So on to slide 44, we've got interactive processing. So this is also known as the transactional processing system. So data processed one transaction at a time. Inputs are noted by the computer, but it deals with them after a short delay. So it spends that delay handling other inputs and managing data movement. So in most cases, you may find that there are systems that are in place where when we input data within that system, it takes time to respond. So this is more of your interactive processing. So it spends that delay when you try to input data. So it does other functions like handling other inputs and managing data movement. So the delay may be so brief that it looks to you as if it has happened out straight away. So once the transaction is accepted, the database will be updated. Like for example, if you use an online system to book a hotel, you will fill in a web form, submit it, and it will come back to you of the room you have booked. So this is similar to what I was trying to explain in terms of the interactive processing. So the process in terms of how it goes about, you book a hotel room, you fill in a web form. So it's just a process. After you've submitted it, it will come back to you to inform you of the room you have booked. So that's more of your interactive processing. So let's move on to the real-time processing in slide 45. So the real-time processing is data processing that occurs as the user enters in the data or a command. So the real-time processing transactions are processed immediately as they occur without any delay to accumulate transactions. So real-time processing is also referred as the online transaction processing. In this case, the records in the system always reflect the current status. So a good example of the real processing would be an airline ticket reservations. When you book a ticket and select a seat, that booking is made straight right away, and nobody else can get that same seat even a second later. Any changes you make to your reservation are also updated in a real time. So that's more of your real time processing. Those are just examples that I've just provided based on the real-time processing, which process immediately. So when you go onto the website and you would like maybe to book on a ticket maybe to Ukraine, and you want to assist the troops of Ukraine. Immediately when you book a ticket, you'll get that a ticket immediately. So that's more of your real-time processing. And also another example is your stock market. When you submit in an order to buy in a stock, that order is processed immediately and not at the end of the day. So let's look at the table which describes the three processing. So you've got your batch, interactive, and your real-time processing systems. So looking at this table, this is just a table that depicts or elaborates further in terms of the processing that we have. You've got your batch, you've got your interactive, and you've got your real time. So based on what we have in terms of the processing, for batch, data is processed in batches. For interactive, data is processed one transaction at a time. For real time, it is assumed that data will be processed as soon as it's received, which is immediately. So in terms of the response time, batch processes is delay in receiving the output from the data. For interactive, any response or update must be completed before the next transition can take place. For real time, the response time, data is processed within a given maximum time limit, usually 4 seconds. And based on the user interface's requirements for batch, no user interaction is required. Batch processes usually take place during the evening or on the weekends when there is less demand on the process. So both of these facts mean daily work can continue with little disruptions. And also with interaction, data inputs tend to be small and output interactively by the user. The user inputs data into the system when prompted to do so, and also their actions are limited to what the system allows them to enter. For real time, the time limit will depend on the number of factors, user requirements, type of processing, and amount of processing. So this just gives more emphasis on how batch in terms of processing it process data for interactive and for real time. So you look into this slide when you try to answer. So let's look into slide 47. Slide 47, we look at the categories of computer system applications in this time. So we're looking at the computer system applications. So we've got the Windows applications, which is a form of based standard Windows, Microsoft Word, Paint, example to the Windows application, and also you've got the desktop application. So these are just your I wouldn't say embedded application that comes with Windows, but it's your suite application that comes with Windows. They are default in default. So if you have your OS, which consists of your Microsoft Word. Microsoft Word it's your office suite that comes with your Windows applications, and also you've got your web applications. So a website is also called a web application. So a web application is just a collection of web pages hosted on a special computer called a web server. So a web server can be located anywhere, and visitors can locate those websites anywhere. So it will work through your browsers, your Internet Explorer. It's outdated. You've got your no, no, it's not. Yes, Internet Explorer. No, it's not outdated. This is your updated version, and also I've got your Mozilla and your Netscape. So this is your updated version, your Explorer. Is it your Explorer? Let's verify. So these, no, yes, in Internet Explorer. This is your Edge. You've got also your Edge for Windows that has been updated. Yep, it's outdated. Internet Explorer, it's updated. We've got your Edge. If you are using Operation OS 10, that's where you can be able to access like your Edge. And on slide 48, we've got your web services. Web services are web applications that give services to other applications through the internet, for example, like your Google search engine, Yahoo search engine, and so forth. So, which it allows other applications to delegate the task of searching over the internet. So, it's more of it does the work for you. So, in as you have explained this a couple of times in terms of me wanting to access certain web pages or maybe certain sites within the network. So these search engine they act as a mediator between you and the site. So all the sites, they have it on their search engine, so it's much more easier for you to go to Google in order for them to actually direct you to the setting. So it uses also an AI, artificial intelligence, in terms of locating you to a certain website or suggesting you some of the website that you will want to access. Also, you've got your console applications, which runs inside the command prompt, like your disk operating system Windows. So it is a lightweight program which is used commonly for test applications. So that's more of your console application. And also we've got your computer system applications, which is your system software, which are designed to provide a platform for other softwares. Example of system softwares include your OS, like your Mac OS, GNU, Linux, Android, Microsoft of Windows, computational science software, game engine, search engine, industrial automation, and software as a service application. So these is more of your cloud-based software applications. So these are more of your computer applications. They differ, it's different. Also, we've got your general purpose application. These are type of application that can be used for a variety of tasks. It's not limited to one particular function. Example, like your word processor could be classed as general purpose software, as it would allow a user to write, create, you write documents, write posters, and so forth. So that's more of your general purpose application. And also you've got the one that I'm using, which is your PowerPoint presentation. That's referred as your general purpose application, because its purpose is to do presentations. And examples of general purpose include word processor, spreadsheet, and presentation softwares, as I've mentioned. Slide 51, we've got the special purpose application software. These special purpose application software is just a type of which the type of software which you can execute one special task. For example, your camera application on your phone will only allow you to take and share the pictures. Another example would be a chess game. It will only allow you to play chess. That's more of your AI type of games that you find on the internet. It only provides one function within it. It's not a simultaneous where you can play and then also. So it's more of your special purpose. And other examples of special purpose applications are your web browsers, calculators, media players, and calendar programs. Uh, and also we have the bespoke application software. So this is just a tailor-made for a specific user and purpose. For example, a factory may require software to run a robot to make cars. So these are just more of your factory kind of applications, where in factories they often use it maybe where they want to create cars, maybe robots, maybe decoders, maybe at multi-choice, for instance. They might use bespoke application software, so it's designed to create software, those kind of applications. So other examples include software for military, missiles, UAV operations, software for hospitals, medical equipment. These are just like your specific kind of applications that you find. So its functions, it's different, it's specific, it's based on a function that is high in demand. So also on to slide 53, you've got your standard suite tools, which you find like your word processor, spreadsheets, presentation packages, and user database packages. Also, you've got your basic user functions of your desktop operating systems, office systems, where we have your electronic mail, conferencing, cooperative work environments, and last you've got your web browsers. So these are just your information systems and computer applications that you have. On to the last slide, it continues further. Your internet and other online services methods, your World Wide Web, FTP, web search engines, and web bots. specialized systems, statistical analysis, expert system, your DSS, GIS, and your BI, electronic data change, enterprise-wide systems, your ERP, CRP, and CSM. So these are just your examples of your information systems and computer systems applications. So it's those applications that you just have to understand its functions, just to understand the concept in terms of this differentiating between this of information systems and a computer application. So let's move on to your learner workbook. So for your learner workbook, activities from your learner workbook, we've got for session 1, activity 1, you need to explain the difference between a standalone computer and a network computer. That's for activity 1. And also for activity 2, you need to write down an explanation of mid-range computers or mid-range systems and a client server model. Activity 3, you need to give the description of characteristic of the configurations. Activity 4, you need to write an understanding of the environmental requirements of the configurations. For session 2, activity 5, you need to describe categories of computer system applications. And activity 6, you need to explain the information systems and computer applications. Activity 7, you need to explain the categories of computer systems applications. And that's it for your formative assessment. Moving on to your summative assessment. Your summative assessment for task 1, you need to demonstrate knowledge of computer configurations and hardware. For task 2, you need to illustrate the advantages and disadvantages of using a network compared to a standalone computer. Task 3, you need to demonstrate knowledge of single processor and multiprocessor. Task 4, you need to distinguish between a batch processing and interactive processing. And task 5, you need to complete the table below. So I've managed to complete this table onto the slides, and you'll be able to match, and I've explained on the onto the PowerPoint slide. So it will be much more easier for you to be able to complete this task 5. So that's it in terms of all the assessment for formative and summative. And please guys, please go through the video so that you can be able to attempt the assessment. And also just to round off, just to round up everything that I've covered for the past 2 videos. I've covered the first unit, the first session, which I touch base on the past, present, and the future computer hardware configurations. And in this video, I've touched base on the categories of computer system application. So please go through this video so that you can be able to attempt your assessment. I've covered all the outcomes for both sessions, session 1 and session 2, and also I've also elaborated in terms of what needs to be done onto the assessment. And if you went through onto the video, you won't be able to struggle in terms of answering the assessment. So that's it in terms of today's session. I'll see you until the next session. Thank you.